So today you guys are solving exponential equations, okay? And these are just the basic ones for today, all right? It's Friday, won't blow your mind yet. Save that for next week, okay? So these are going to be the easier ones, okay? We're going to be solving exponential equations. That's going to be the goal. By the end of this, you should be able to solve the basic ones, okay? We'll do the more advanced ones a little bit later, especially after we go over logarithms as well, okay? So first off, when you're solving an exponential equation, you must know what it is. It is when the variable is in the exponent. That's what makes it an exponential equation, when your variable is in the exponent instead of something being, like a variable being raised to like a 2 or something like that. And we can solve these equations by rewriting both sides of the equation with a common base. Okay, so when you're presented with an exponential equation, you'll know it's an exponential equation because, again, your variable is going to be in the exponent. All right, and to solve these simple exponential equations, you're going to be able to rewrite both sides with a common base. So let's practice that. How do you rewrite 32 so that it has a base of 2 raised to a particular exponent? How can I rewrite 32 so that 2 is its base and it's raised to some exponent that will give me 32? This will be 2 to the 5th power. Yes, knowing your powers of like 2 and 3 and 4 and 5 are going to come in handy here. And this is basically saying that 2 times 2 times 2 times 2 times 2, that should give you 32, which it does, okay? You're going to need this skill in order to solve these types of exponential equations, being able to do this, all right? How can I rewrite 4x so that it has a base of 2 raised to a particular power? 2 to the power of 2x, not x squared, okay? Because think about it. This is 2 times x, okay? So this works because this is basically written like so, like a power to a power. 2 squared is 4. Then it turns into 4 to the x. Are you following me here? That's why that works. And then the x just gets attached to it on the end, okay? What about 16? How do I rewrite 16? Think about it. How many times I have to multiply 2 by to get 16? Say again. It's 4. So 16 can be written as 2 to the 4th power. Now there's already a 2x that's on the outside. So what am I going to do with that 4 and that 2x? So this is basically going to be 2 to the 8x. Okay? Questions up to here? Okay? So remember, you're basically rewriting the bases, guys. The bases. Okay? Move on to the fractions. What question? Oh, you're going to say the answer. Okay. What is the answer? 2 to the negative 3rd power. Because think about it. When you have a negative in the exponent, to make it positive, don't you flip it and it becomes 1 over that? So yes, 2 to the negative 3rd power is how we can rewrite a fraction. Okay? Another way to look at it, you can rewrite 8 as 2 to the 3rd, but you can't have 1 over your base. So you make it negative, and that's how you get 2 to a power. So far, so good? Okay. What about this one? It'd be 2 to the negative 4x. Again, if you rewrite 4, excuse me, that becomes 2 squared, and there's already a 2x out there. So then you just multiply those together. And then, of course, you make the exponent negative to get rid of that fraction part. Okay? So these arrows basically indicate like the path that you're taking to get to the answer. But that's the skill that you need to solve these problems. So 2 is probably the easiest base that there is, okay? What's 3 squared? 3 to the 3rd? 3 to the 4th? 81. What about 3 to the 5th? Not 264. 243. 243, okay? These are good things to know because I'm going to kind of let you a little bit of an advance. There's a potential that you might not be allowed to use your calculator, okay? So knowing your powers, or at least being able to do this right here, okay? And then this makes this, and to keep on going, you need to have that skill, okay? If you don't know them off the top of your head, all right? What about 4 squared? 4 to the 3rd? 4 to the 4th? Anybody know what 16 squared is? 256. Okay, we don't know our perfect squares. All right. Okay, it's 5 squared. 5 to the 3rd. Okay, what about 5 to the 4th? Huh? Oh. Ooh. Say again. 625. Oh, so speak up, Jesus. Oh, okay, y'all. Hold on. Let me pause in the video. Gonna have a heart to heart with my class real quick. Anybody watching this? All right. So your steps for solving these equations. You rewrite both sides with the common base. That's why you need that skill. That's step 1. Find that common base. Rewrite both sides of the equation with that common base. Because after you do that, you're going to set your exponents equal to each other. After you do that, you're going to actually solve the equation. Okay? And it could be something as simple as a linear equation or a quadratic equation. After that, you always want to make sure you check your answer to make sure your answer makes sense. Easy enough? Okay. Well, let's go ahead and let's get to it. Open up your foldable or your sheet of paper. If it's not foldable, you just fold it in half. Okay. The other 2 that are on the left side of your paper, I forgot before I made the copies to add in the fractions, so you're going to need to add in those blue fractions. You'll see that it's missing the 1 over 81 and the 1 over 125. Okay. All right. So step 1 says you need to rewrite both sides so that they have the same base. Okay. If I look at 8 and 4, what is going to be that common base that 8 and 4 both have? 2. Because there's no way you can rewrite 8 that's 4 to a certain power, but you can rewrite both 8 and 4 to where it's 2 to a certain power, right? 8 can be written how? 2 to the 3rd, and there's an x there. And then 4 can be rewritten how? 2 to the 2nd. That's step 1. Rewrite it so that you have the same bases. Step 2, you have to do what? Equal to each other. So at this point, you drop your bases and then you just set your exponents equal to each other, and then you solve. Yeah, they cancel out. Yes, you can do this, I promise. Then you just solve. You divide by 3, x equals 2/3. Let's check it. So when you go back in and you check, you have 8 to the 2/3 equals 4. Now, I didn't do a foldable on this. This is where I'm teaching this concept. You have a fraction in your exponent. Okay? You have a fraction in your exponent. It's okay. You can do this. The general rule is when you have a base raised to a fraction that's an exponent, that can be rewritten. I feel like I've done this before. I have? Okay. If not, here it is. There's a review for it. Okay? It becomes the nth root of a to the n power radicals. We did do this before. Okay? And so to check to see if 8 to the 2/3 actually does equal 4, we can rewrite it as the what root? Cube root of 8 squared, which is 64. So you can either square 8 and then take the cube root, or you can take the cube root of 8 and then square it. What's the cube root of 8? And what's 2 squared? 4. So yes, this is the right answer. Okay? So that's another older skill that we've done that you'll need for this. The second one, that's 27 to the x equals 1 over 81. How can I rewrite this so that it has the same common base? It's going to be 3. If anything, think to yourself, okay? I need 27 to 81. Where have I seen that when I have a number raised to a particular power? Well, that would be 3. 3 to the what power gives me 27? 3 to the third power. And then what about 81? 3 to what power gives me 81? It's 4, but then to make it so that it's not a fraction anymore, you make it negative. That's step 1. Step 2, exponents equal to each other. Solve. X is equal to negative 4/3. You plug it back in to check. That's 27 to the negative 4/3. How do I make that exponent positive? You flip it. And then I can rewrite 27 to the 4/3 as a radical. What root? Cube root, 27 to the 4th. Now again, don't know if you're going to have these calculators, but you can tell me what the cube root of 27 is. And then what's 3 to the 4th power? 81. Hence, knowing those powers makes things a little bit easier. Are you okay? Am I going too fast? Are there any questions? So really, truly, it's 3 steps. You just check to make sure it works. Step 1, get the same base. What base am I going to use? So this one's not going to change because it's already to a base of 5, but 1 over 25, 1 over 125 is going to become what? 5 to the negative 3. Anytime there's a fraction involved and you want to rewrite it so that it has a common base, more than likely your exponent is going to be negative. Drop my bases and set my exponents equal to each other, and x is going to equal negative 1. And when I plug in the check, that becomes 5 to the negative 3rd power, 1 over 5 to the 3rd power, which is 1 over 125. Questions? Get that common base, get that common base, get that common base, okay? Moving forward. These two. What's my common base? 3. This one's not going to change, but what's 243? How can I rewrite that? 3 to the 5th power. I wasn't doing those for my health. Okay, I wasn't doing those for my health. Okay, knowing these makes things a little easier. Step 1. Step 2. Set those equal to each other. The exponents equal to each other. Now, instead of this being a 1-step equation, this is now became a 2-step. Subtract 1. Divide by negative 2. And becomes x is negative 2. While everyone else catches up, a quick check. Negative 2 times 2 becomes 4. 1 plus 4 is 5. And yes, 3 to the 5th power is indeed 243. You guys got this? Can you guys do the next 2 on your own? Okay. I'll check back in. All right. So, what base did you rewrite this one to? 3? Guess? Okay. 3 to the what is how you rewrote 9? 2x minus 5 equals 3 to the third. Now, before you drop your exponents, please make sure you take care of that. Okay, this is 2, and it's being raised to the power of 2x minus 5. Power of a power says that you need to do what to these? You need to multiply, and yes, you're going to distribute that 2 to that 2x and the 5. So then it becomes 4x equals 3 once you drop the exponents. So then you're going to do what? Add 10 and then divide by 4. So x equals 13 over 4. Okay? If you check, it's 9, 2 times 13 over 4 minus 5. Okay? What's 13 over 4 times 2? And 26 over 4 reduces down to be what? Okay, if I use 6.5, then what's 6.5 minus 5? So I have 9 to the 1.5 power. Now I'm going to take this back to a fraction so that way we can do this without a calculator. What's 1.5 as a fraction? Huh? 1 and 1/2, which becomes 3/2. So this is the same thing as saying 9 and 3/2. Okay? Which means that now I can rewrite it using the radical part. What's my root? It's the square root. 9 to the third power. What's the square root of 9? 3 to the third. There you go. This one. What's my base? So this one doesn't change, but to what? So I'm going to apply that property, power of a power. 2 times 2x becomes? So I have 4x equals 3x minus 8. The easiest way would be to subtract 3x from both sides, and x equals negative 8. Okay? Quick check. And we have one more. Okay? What's 3 times negative 8? Negative 24 minus 8 becomes? Negative 32. I don't know what 5 to the negative 32 power or what 1 over 5 to the 32 power is, but I'm going to use my rules and my laws to still check to make sure that the left side equals the right side. What's 2 times negative 8? And can I rewrite 25 to have a base of 5? 5 what? What do you do to the exponents? And what's 2 times negative 16? Okay, so it works. I just got to make sure the left side equals the right side. Now this question that I have here, okay, please make sure you get it down, okay? Please make sure you get it down somewhere, all right? Yep. Make sure you get this down. It is 4 to the negative n plus 2 times 64 to the n equals 16 to the 3n plus 3. Okay? Still, 3 steps. First step is to do what? It's the same base. What base? 4. Okay? So this one's not going to change. But this 64 is going to turn into 4 to the third power. And that in there is going to get Multiply. So it goes 3n. 16 is 4 to the second. And then there's that whole, all this business there. It's a power to a power. So on the right side of the equal sign, I got to multiply. So what does my exponent on the right side become? 6n plus 6. And on the left side, I have to what? I have to add the exponents because the bases are being multiplied. Product property says that when you have the same base and they're being multiplied, you add the exponents. So then this becomes negative n plus 2 plus 3n. And only at this point can I drop the bases and set the exponents equal to each other. Yes. Yes. Because remember, our product property says that if the bases are the same, then all we do is add the exponents, but we actually don't multiply the bases together. So this rule is the rule that's being used here. So now we can set our exponents equal to each other and solve this. So now it's step 3. So this becomes 2n plus 2 equals 6n plus 6. 1, negative 1, because I subtract 2n, subtract 6, and I have negative 4 equals 4n. So n equals negative 1. They can get, more involved like these because, you're still applying the properties to solve these equations. Does everybody understand how we were able to go from that first orange line of rewriting the bases to that second orange line? Okay. Well, that is how you solve exponential equations by using the common base rule. Sure can. Let's check it. Thank you for holding me accountable. Negative n. Negative n becomes a positive 1 times 64 to the negative first power equals 16 to the negative 3 plus 3. What's negative 3 plus 3? So 16 to the 0 power is? So that means this whole left side should equal 1. Okay? What is 4 to the third power? 64. And how can I rewrite 64 to the negative first power? And what's 64 times 1 over 64? Okay. Because that becomes 64 over 64.